So up next, we have Dr. David Maxwell from MD Anderson Cancer Center, who will be speaking on MLPrE, which is a tool for pre-processing data and conducting exploratory data analysis prior to machine learning model construction.
Yes, thank you for giving me the opportunity to talk. I'm going to talk about MLPrE. It's a tool that we've developed as part of a COVID-related project. So what is MLPrE? So it's a pipeline tool. It's written in PySpark, and it's for doing pre-processing and EDA tasks. We use stages described by JSON with data passed between those stages using a Spark data frame. So our motivation for this tool was that data preparation and EDA consume a significant portion of the time by data scientists. And it's critical to prepare this data correctly and make sure that we can reproduce results. So we needed a tool that could process larger data sets, in other words, be scalable. Furthermore, we wanted that tool to perform efficiently in a lengthy workflow such as Airflow, where we would be calling other types of procedures. So pipelines are useful. They describe a process of filtering and transforming the data, and they connect components together to accomplish a larger task. They may be created visually through a script or through a data interchange format such as JSON and YAML, and that's what I'm going to be focusing on. So how is JSON YAML being used by others to direct code and or pipelines? Well, Deep Pavlov uses JSON as configuration for their open domain question and answering. Azure uses YAML to define ML pipelines, and CA Enterprises has pipelines as a code feature, which uses JSON as format. And if JSON, I have a link down here to JSON to YAML conversion. So using JSON to direct the code. So on the left, I show basically the input JSON example where in this case, I'm looking at filtering a column on values and ensuring those are what gets picked up in the data frame. On the right, I show a piece as I'm reading in the input of the JSON, and then that's basically directing a data frame to filter down here on the bottom, filter a column, and if it's in that set of values. And so what I'm using here, this is code in Spark. It's a data frame, which is similar to Pandas or R data frames. And you can think of the data frames like a spreadsheet, basically a 2D set of tabular data. So this is great. We can direct the code, but it's really up to the code to determine the order, the way we have it written. And the tasks are not very general. So what if we wrapped everything inside a stage and put this in a particular order? Well, that's sounding a lot like a pipeline. So how do we make the pipeline? Well, we select a programming construct, in this case, PySpark, which is basically Spark with Python as a programming language. We chose the method to interchange the data between that, and that is Spark data frames. And then finally, we have a flexible route for defining those stages. And at this point, we've selected JSON. So this is just a little bit of the JSON on the left, showing multiple stages, focusing just on a very simple one. In this case, we have a stage name, stage type, stage param. This one doesn't have any parameters. It's a very simple one, just to drop nulls, right? So on the right, we have the code to recognize that stage type and then call a function called drop null simple with the data frame, and then basically dropping the nulls and returning the data frame. And the same would be done for the others, although you would use the stage params to modify those. So the code developed by our data science team is called MLPrE. Initially, we started out using Pandas data frames, but ran into memory processing issues to work with large files for this COVID-related project. And so we decided to rewrite in Spark, and then ultimately ended up generalizing it and putting it into a pipeline. So this is the generation we're in right now. So here are the stages implemented so far in MLPrE. We have exploratory data analysis stages, doing things like features extents, feature types, looking at the types of the data you have, looking at the number of complete observations you have, doing correlations between columns. Of course, we have basic input-output, removing nulls, keeping or filters to keep or remove records, showing the data frame, sampling from the data frame, and so on and so forth. Port 1 is actually the SQL part of this, so we can actually run SQL queries on this, and that's very powerful. Feature and engineering, we have math columns, combining the columns, expressions, computing things like Lagrange sign distances between columns, and other types of functions like date and time, which are useful. And also, we've extended this to add in plotting so that we can do box plots, pair plots, scatter plots, and so on and so forth. First example, and all these are actually from the UCI machine learning repository, but this is the WILT data downloaded, and I'm showing an example on encoding ranges for within these stages. So I have two different stages here, one encoding as low, medium, and high, and the other one encoding as integer values. And you can see in blue the GLCM pan, and then that getting converted into GPR, and then the SD pan getting converted into SPR column based on a matching of these ranges here. The next example is the QSAR bioconcentration data set, and these equations are they don't mean anything, but it was basically just to show how you could use a math and expression to obtain a new column for your data set for feature and engineering here. Right now, you'll have to provide the correct order of operations, but later on, we hope to be able to incorporate some functions for that. Third example is actually exploratory data analysis, and I show here feature type analysis and complete observations. So on the right is the feature type, so I'm looking to get some idea of what is in my data set fairly quickly. So I can look at what the column types are, how much is percent filled, whether it's categorical based on a cutoff or not, and then also look at, you know, how much is percent null or percent blank in my data set, and then we can use that to quickly list potential features that we want to remove from our data set. So last example is a plotting example, and so we in this particular case, we take the occupancy detection data, also from the UCI machine learning, and the first one is a scatter plot, and you'll see that I have both X and Y columns specified here. I'm only showing one of the plots here. What was interesting about this is that they actually, in the paper that was cited, they talk about how light is important for determining this occupancy. So I just thought that was interesting. That came right out of plotting this out. Second one was a box plot. In this particular case, I'm actually using something I've added, which is process all numerical and process all categorical. So you can actually, like, say, if you have several hundred different columns in your data set, you can actually just have it process all of the combinations and then just look at each of these visually fairly quick and see if there's things of interest from it. So finally, we want to incorporate MLPrE into a larger workflow. And so what I'm showing here is basically a section of an Airflow DAG. It's a graphical representation. And highlighted here is the Spark preprocess, which is basically calling this MLPrE code and running a Spark job on this to prepare the data for the rest of the stages here. And the ultimate thing is basically to do several different models and gain a consensus of those. We needed to get this data basically consistent for different models. For Spark models, we wanted that data to go into Hive, and for the other ones, we wanted a CSV file output from this. So this allowed us to actually incorporate this within and then run other operators within Airflow. So what's the future for MLPrE? So I hope to be able to allow some intermixing of pandas and Spark data frames if that is if the memory constraints or the processing constraints are not too high. Also would like to be able to work with more than one data frame. We would like to be able to combine, for example, maybe a data frame with an outside table, like a Hive table or something. I've recognized the need for having some global variables that pass through. So right now, the data frames are essentially what's passed between each of the stages, but sometimes it's useful to have variables that kind of hold on to that through the different stages. And finally, rewrite this more with Python class. So at the end here, I'm going to acknowledge others. This was a team effort. So management for our data science team, Melody Page, our program manager, Mary McGuire, BSA for this team, Brian Dyrud. Of course, our data science team, Yai Zhang, Jim Lomax, and Rob Brown. Hadoop cluster administrator, Daniel Wang, and then a sponsor of a project for initial developing testing, which was Dr. Caroline Chung and Rad Onk. And finally, I'd like to thank you for your time, and willing to take a few questions if there's time.
Great, thank you very much. So one first question, you mentioned Python, but do you have other plans to make this available for use by people at other institutions?
Well, right now, I'd like probably to clean up the code a little bit and add some more features to it. But yes, if it makes sense and there's interest in this, yeah.
Great. And is this targeted at specific domains, or are there assumptions about the data model that makes it suitable for specific domains, or is it just bring any kind of data that you have?
Well, I think the goal is that this be as general as possible for data science. Obviously, we were using it for the project was NLP data that was extracted out, and we were using this to solve a particular issue we had in pre-processing. And we recognized the fact that there were certain steps that were general that we needed to keep doing over and over. And as a matter of fact, the process may change a bit as we needed to prep the data for the machine learning model. So yeah, there's nothing domain specific about this. So.
Gotcha. Very nice. All right, why don't we move on to the next talk if there are no other questions. So